Hello everybody, welcome back to Learning the IGCSE curriculum with Omar. Today we're going to be diving into a topic from additional mathematics called circular measure, and we're going to learn what it's all about. Now circular measure is all about dealing with angles in a circle and also the arc lengths in a circle. But instead of using degrees, which is the standard measurement or unit we use to measure angles, we use radians. Now, this might sound a bit confusing at first, but don't worry. By the end of this video, you'll see how simple it really is. Okay, so let's start with the basics first. Now, in a circle, when we draw a circle, right, here's the center. When we take one entire revolution around the circle, we get what? We get 360 degrees, right? This is going to be 360 degrees. Now this is measured in degrees, correct? Now instead of using degrees, we want to use radians. Now to convert 360 degrees into radians, it's actually equal to 2 pi radians. You can write radians as rad or rad. So 360 degrees is actually 2 pi radians. Okay, so if you continue using this logic that 360 degrees is equals to 2 times pi radian, then that means 180 degrees, right? 180 degrees should be equal to pi radian. Because if you divide 360 by 2, you get 180. If you divide 2 pi by 2, you get pi, right? So just like that, 90 degrees is going to be what? 90 degrees will be pi divided by 2 radian, because we divided 180 by 2, so we got 90, and pi divided by 2, pi over 2. Okay, so now the question is, how do you convert between degrees and radians? Now this is actually very straightforward. You just have to follow two very simple formulas. So if you want to convert from degrees to radians, what you need to do is you're gonna have to multiply the measurement you have, the angle you have in degrees, with pi fraction 180. So whatever number you have, for example, let's say 60 degrees, you're going to have to multiply 60 degrees with pi over 180. And then the value you end up with is going to be in rad. Vice versa, if you want to convert radian to degree, then you're going to have to multiply your value with 180 over pi. Now these formulas are very simple to follow, so let's use a few examples to further demonstrate what this means. Okay, so if we want to convert 60 degrees to radians, we're going to multiply 60 with pi over 180. So now what does that equal to? You cancel the zeros, you simplify. 6 1s are 6, 6 3s are 18. So you're left with pi over 3 radians. So that means 60 degrees is equals to pi over 3 radian. Okay, so here's an example you guys can try for yourself. You're gonna have to convert pi over 4 to degrees. You guys can pause the video and give this question a try. Just get a paper and a pencil and give it a shot. Okay, so next we're gonna learn about the arc length of a circle. Now before we get started with the formulas of how to calculate it, let's understand what it actually is. So in a circle, let's say we have a circle, right? And then we have a center. When there are two radiuses inside the circle, so like this, something like this maybe. So when you have two radii meeting at one point, this is going to be called a sector. So this shaded region is called the minor sector because this is a smaller part, and then this bigger part is going to be called the major sector. So when you have a circle looking something like this length here, this edge of the circle that is connecting the two radii over here is going to be called the arc. So this is the arc length that you're supposed to be finding. Now how do you calculate the length of the arc? Now you also again have to follow a very simple formula, which is going to be length of arc equals to r theta. So length is the arc length, r stands for the radius, and theta stands for the angle, the inner angle of the sector, this angle here. So when you multiply the angle inside of the sector with the radius, you're going to get the length of the arc. Okay, so let's try an example here. In a circle, we have a radius of 5 centimeters and an angle that is subtended by the arc length of pi over 4 radians. Now, if you want to find the length of the arc, what we're going to have to do is follow the formula we have here. Length equals to r theta. So what will that be? That will be length equals to 5 times pi over 4, which is equal to 5 pi over 4. So 5 pi over 4, the unit over here is centimeters. So we're going to use centimeters. So 5 pi over 4 is the length of the arc. Lastly, let's discuss the area of a sector. Now, to find the area of a sector, what you're going to have to do is you're going to need the length of the radius and also the angle given of the sector. So that means the formula to find the area is going to be given as angle equals to half times r squared times theta. So A stands for angle, half times radius squared times the angle of the sector. Let's look at a few examples where we can apply this formula. Okay, so we have a circle here with a radius of 3 centimeters and an angle given of pi over 6. Now, if we want to find the area of this minor sector that we have here, we're going to have to follow the formula as given earlier, which is 1 over 2 r squared theta. So let's substitute the values into this formula. So we're going to get half times 3 squared times pi over 6. So now what is that equal to? That's equals to 1 over 2 times 3 squared is 9. 9 times pi over 6 is going to be 9 pi over 6. So 9 pi over 6 times half is equals to 9 pi over 12. After further simplifying this, which would be 3 4s are 12 and 3 3s are 9, the answer that we get is 3 pi over 4 centimeter square. 3 pi over 4 centimeter square is the area of this sector. Okay, so that's it for today's video, folks. This was circular measure. We just covered some of the fundamental concepts such as the area of sector, how to find the length of the arc, and also how to convert between degrees and radians. If you guys need any further support in this chapter, please make sure to leave your doubts in the comment section below. If you guys enjoyed this video, please leave a like and make sure to subscribe to my channel. Until next time.